kiddos. I'm certain we need to practice a few more Hess's Law problems before I cut you loose and have you do some on an assignment. I also want to show you a shortcut version of Hess's Law, but I'm going to show that to you at the end of the video as opposed to at the beginning. So what we're going to start with are a couple of the problems I've given you. I want to find the delta H for the following reactions. So we'll do A and we'll do B. And I want you to use the heat of formation data from your manual, and I also want you to use the formal use of Hess's Law. So remember how I like to do these. I like to draw a line. Okay, so let's draw a line, and I'm going to write down the reaction that I want underneath that line. So the reaction I'm after is for two NaHCO3s reacting to form Na2CO3, CO2, and it looks like liquid water. Okay? Now, we have some equations that we can write. Don't we know the heat of formation reaction for my products? Don't we know, for instance, that to form Na2CO3, I need sodium, I need carbon, and I need oxygen. Now let's balance that equation for the formation of 1 mole of Na2CO3. Looks like I need to put a 2 in front of Na, and to get 3 oxygens, I need 3 halves of an O2. Now, I can look up the heat of formation of this reaction from the data table in my manual. So let's go back to my manual and find the heat of formation of Na2CO3. So Na2CO3, let's pinch this, make it a bit bigger so we can see it. Looks like the heat of formation of that compound is negative 1130.7. So the delta H of that formation is negative 1130.7 kilojoules. Okay? All right. We're also making carbon dioxide. So I'm going to put CO2 on this side, and let's write its heat of formation reaction, which would be carbon plus O2. And let's look up that heat. And so carbon dioxide on my data table over here, CO2. Let's see if we can find it. Here we go. Is negative 393.5. So negative 393.5 kilojoules. And we're making liquid water here. So we're going to make H2O liquid, and that would be H2 plus 1/2 of an O2. And we can look that heat up as well. So H2O liquid, careful you don't use the one that has G after it, we want the liquid, is negative 285.8. Negative 285.8 kilojoules. So we've gotten all 3 of my products taken care of, Na2CO3, CO2, and water. Now my reactant here I need to decompose. So I'm going to start out with NaHCO3, and we're going to decompose that into its elements. And of course that would be Na, H2, C, and O2. Aren't those the elements that make up NaHCO3? Now let's balance this. 1 sodium, we need to have 1/2 of an H2 right here, and 3 halves of an O2. Now, I can look up the heat of formation of this, but remember, I'm not forming it on this problem, I'm decomposing it. So we're going to have to switch the sign. So NaHCO3, that's right there. So the heat of formation is negative 950.8. So we want to put a positive 950.8 kilojoules. Now it looks like I want to go ahead and decompose 2 of those, so I need to double this. And I need to double the heat then, don't I? Now, if these 4 equations add up to be the equation I'm after, I can then add their heats together to get the heat for that reaction. So let's take a look. Now what can we cancel out? It looks like I have a carbon here and here. That's 2 carbons on that side. And don't I have 2 carbons on this side that I can cancel out? It also looks like I have an oxygen here, 1.5 oxygens here and another half of an oxygen here. So that's 1.5, 2.5, that's 3 oxygens here. And I have 2 times 3 halves, that's 3 oxygens there that can be canceled out. Is there anything else I can get rid of? Let's take a look. Looks like I have 2 sodiums here that I can cancel out, and 2 sodiums here that can be canceled out. And everything else looks like I have to keep. So I have 2 NaHCO3s on this side of the equation. Oh, hold on, looks like I had to get rid of this H2, and I have 2 halves of an H2. Yeah, those can be gone as well. All right, then I have Na2CO3 on the product side, CO2 on the product side, and water on the product side. Yeah, it looks like those equations add up to be the equation that I'm looking for. So I can add up these heats, and I can get the heat of the reaction that I'm looking for. So let's get out our calculators, and we're going to go ahead and plug in negative 1130.7, and we're going to add to that negative 393.5, and we're going to add to that a negative 285.8, and then we're going to add to that, we're going to use my parentheses key, 2 times a 950.8. And I end up with 91.6 kilojoules positive for the heat of that reaction. Okay, now that one was sort of tough. I don't think I would, well, on an exam I probably won't give you one that difficult, but that was sort of a tough one. Let's try another one, okay? Let's try letter B here. So on letter B, we have 2 C2H6s and 7 O2s make 4 CO2s and 6 waters. So let's find the heat of that reaction. So let's draw a line again. And we're going to have 2 C2H6s plus 7 O2s react to form 4 CO2s and 6 H2O. This time we're using water gas. And why don't I stop and pause for just a minute? Why don't you try to finish this without my help? See how you do. Okay? See you in a sec. All right. Did you start out with your products being formed? Did you make CO2 from the elements C plus O2? Now let's look up the heat of that reaction. I think we did earlier on a previous problem, didn't we? Here it is. CO2 is negative 393.5. Negative 393.5. Now it looks like we need to make 4 of those, don't we? So I need to quadruple this and quadruple the heat. All right, we're also going to make water gas. And that comes from H2 and a half of an O2. So let's look up the heat of formation of water gas. And here's water gas. Looks like it's negative 241.8. Negative 241.8. Now, we have to six-tuple that, don't we? So I'll put a 6 here, and we have to six-tuple my heat. So I've made 6 waters and 4 CO2s. Now, for my reactants, I need to decompose those. So C2H6 will decompose into carbon and H2. So that would be 2 carbons and 3 H2s. Well, let's look up the heat of formation of C2H6, but since we're decomposing it, we'll have to switch the sign. So, where is C2H6? Here we go. C2H6 is negative 84 if we're going to form it. So if we're decomposing, it'll be a positive 84.0. Now let's see, I need to do that to 2 of those, right? So I need to double this and double my heat. Now let's check to make sure these add up to be the equation that I'm after. These 4 carbons are canceled out by those 4 carbons. What else cancels out? Let's see. These 6 H2s are canceled out by those 6 H2s. And it looks like I'm left with these 4 oxygens plus these 3 oxygens for a total of 7. Perfect. And I have 2 C2H6s. Perfect. I'm making 4 CO2s. And I'm making 6 waters. Yeah, so those equations add up. So now I can add their heats together to give me the heat of that reaction. Okay, so let's see what we end up with here. So we'll pull out our calculators, and we have 4 times a negative 393.5. We're going to add to that, we're going to use our parentheses key here, kiddos. 6 times a negative 241.8, close parentheses. And we're going to add to that, parentheses, 2 times 84.0. All right, and I get, boy, negative 2856.8 kilojoules of heat being released from that reaction. Okay, so that is using the long version of Hess's law. Now I promised you I would show you a shortcut, didn't I? So let's go back to our notes and let's take a look at this section here where it says, this method will always work, but it can be tedious, as you've learned. There's a shorter way that will also always work, and it accomplishes the same purpose. It's called the summation equation. The heat of a reaction can be found by taking the sum. So that Greek letter, it's a capital Greek letter sigma, means sum of the heat of formation of the products minus the sum of the heat of formation of the reactants. We do not have to worry about changing signs using this summation equation. So let's jump right into this and do example 6. And let's use this short version of Hess's law to calculate the heat for the combustion of ethane, C2H6. Now you'll notice that this is a problem that we just did a moment ago on our notebook. So let's try this. C2H6 combustion, so we're going to react it with oxygen, and we will form carbon dioxide and water vapor. Now to balance this, we'll put a 2 here, and a 4 there, and a 6 there, and that gives us 7 over here for O2s. Now what we want to do is we want to take the sum of the heat of formation of my products and subtract the sum of the heat of formation of reactants. So I'm going to do these guys first over here. I'm going to use little brackets. 4 times the heat of formation of carbon dioxide. So we're going to have to look that up, plus 6 times the heat of formation of gaseous water. So let's look up CO2's heat of formation and gaseous water's heat of formation again. Boy, we're looking these up a lot, aren't we? CO2, negative 393.5, gaseous water, negative 241.8. So, whoops, negative 393.5 for CO2, negative 393.5, and negative 241.8 for my water vapor, minus the sum of the heat of formation of my reactants. So my reactants, kiddos, are going to go over here. So I have 2 times the heat of formation of C2H6. So let's look that up again. C2H6 heat of formation is right over here. It's negative 84. All right, so let's put in negative 84. I'm not changing the sign. You'll notice I don't need to because when I subtract a negative, it's like adding a positive. At any rate, I'm also going to add the heat of formation of my 7 oxygens, and that's going to be 0 because oxygen is an element, and the heat of formation of elements are 0. So let's see if the short version of Hess's law works. If I add these together and subtract these, I should end up with the same answer I got just a few minutes ago on my notebook. So let's try this. 4 times a negative 393.5 plus, I'm using my parentheses, 6 times a negative 241.8, close parentheses, and this time I'm going to get an answer and then subtract that answer from parentheses 2 times a negative 84. And I get negative 2856.8 kilojoules of heat for that reaction. Now, let's use this answer and compare it to the one we got in our notebook just a few minutes ago. So in our notebook, we did it the long way, and we also got negative 2856.8. So the short version's much less tedious. Let's try the short version for this problem up here. So I want to take the product's heat of formation and subtract out the reactant's heat of formation. And hopefully the answer I get will match the answer I got when I used the long version of Hess's law earlier. So Na2CO3, the heat of formation of that is negative 1130.7. We looked that up earlier. Plus the heat of formation of CO2, negative 393.5. We looked that one up earlier. Plus the heat of formation of water, and this is liquid water, kiddos, negative 285.8. Minus the heat of formation of my reactants. So here are my reactants. This is just NaHCO3. There's two of those, and that would be times a negative 950.8. Remember, when you use the short version of Hess's law, you don't need to change the sign, because when we subtract that negative, it's almost like, well, it is like adding a positive. So let's do the math here and see what we get using the short version of Hess's law. So we have negative 1130.7 plus a negative 393.5 plus a negative 285.8. We're going to get a total there, and we're going to subtract out parentheses 2 times a negative 950.8, and I get 91.6 kilojoules, and that's a positive number. So yeah, that does work. So hopefully, we'll practice a few more of these, by the way. Hopefully you guys will enjoy using the short version of Hess's law while understanding the longer version. Okay, I hope that was helpful. We'll see you all soon. Bye-bye.